My name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 903. Please turn to it, page number 903, section 5 of exam number 9. There are 20 questions in this section. They are all of the same type. They are multiple choice questions. Unlike the previous section that we just finished, which had multiple choice and the gradient question mixed in here. Here, they are all multiple choice questions. They are all of the same type, and therefore the scale of difficulty goes all the way from 1 through 20, which means the first 6 or 7 are going to be easy, the next 6 or 7 in the middle are going to be medium, and the last 6 or 7 problems are going to be hard. Number 1 is number 1 on a scale of 1 through 20 is very simple. In the sequence above, so they give us a sequence here which looks like this: 2, 6, 14, 30, and so on and so forth. It says in the sequence above, the first term is 2. Alright, we see that. Each term after the first term is obtained by adding 1 to the preceding term and doubling the result. For example, this term is obtained by adding 1 to the preceding term, which was 2, and then doubling the result. 2 times 3 is 6. And then similarly this one, once we get the 6 here, we add 1 to it, we get 7, and we multiply by 2 and we get 14. We get to this one again, once we have the 14 here, we add 1 to it, and then we double it. 14 plus 1 is 15, plus times 2 is 30. I don't know why I'm explaining so much, it's very simple. The question is, what's the 6th term in the sequence? So we have to find the 5th term and the 6th term. Well, this is 30, so the 5th term is going to be, this is 30, so we add 1 to it, 30 plus 1, which is 31, and we double it. 31 times 2 is 62. That's our 5th term. And therefore the 6th term is going to be, once we have the 62, we take that, we add 1 to it, and we double the results. So it's 63 times 2, which is 126. The answer is E. Next one, number 2. Number 2. We are told that A times x plus y equals 45. We are also told that A times x equals 15. The question is, how much is A times y? Well, let's find out, shall we? We open the parentheses, we get A times x plus A times y, which we are told is 45. Now A times x we are told is 15, so we can put it here. A times x equals 15 plus A times y equals 45. Subtract 15 from both sides, and A times y equals 30. Number 3 on the next page. I need to change my marker because this one is not writing very well. So we'll see what we can do. Number 3 on the next page, page 904. In the speedometer above, what is the speed in miles per hour indicated by the needle position? I'm not going to reproduce this thing. I'm just going to show you here that this is where they show 30, right here. And then we're looking for miles per hour is what we're interested in. Miles per hour. So we have to look at the one in the middle. Look at the one in the middle, obviously, because the one in the bottom is feet per second and the one in the top is kilometers per hour. If you look at the one in the middle, from 30, which is in the middle right here, to 60, 30 to 60, we see how many marks? We see 1 mark, we see 2 mark, and we see 3 marks. So this is 1, 2, 3, and 4. So 4 tick marks. 4 tick marks equal 30. I said 4 and I wrote down 2. 4 tick marks equal 30. Again, one more time. From here to here is 1, and then from here to here is 2, and from here to here is 3, and then finally we get 4. And the part that they're showing here is right here. So this already is 30. If we can figure out how much is one tick mark, we just have to add to it, and that's it. So 4 of them are 30, which means one tick mark. One tick mark is 30 over 4. Half of 30 is 15, and half of 15 is 7.5. Half of 15 is 7.5. This is 30 already, so the very next mark that they show is here is going to be 30 plus 7.5 or 37.5. The answer is B. So I have to find a marker now because these are both not working here. Next one, number 4. How many different positive 3-digit integers, they have to be positive 3-digit integers, they have to be whole numbers, that can be formed, we are asked, if there are 3 digits 4, 5 and 6, if the 3 digits 4, 5 and 6 must be used in each of the integers. We cannot leave anything out, and obviously since this is a 3-digit integer and since we are asked to use all 3 of them every time, that means we are not allowed to repeat a digit. So let's start. 4, 5, 6 is what they're giving us. 4, 5 and 6. Very simple. Leave the 4 the way it is and switch 6 and the 5. So that's the pair. Now start with 5 and then we have a 4 and a 6. Leave the 5 where it is and switch the 4 and the 6. That's another 2. Now start with 6 and we have a 4 and a 5. Leave the 6 the way it is and switch 4 and the 5. Well, that's it. There are 6 of them. The answer is C. There are 6 of them. Number 5. Number 5. There were 6 of them. There are 6 3-digit integers containing 4, 5 and 6. 456, 465, 446, 546, 564, 645 and 654 as we just saw. Number 5. The 3-dimensional figure represented above consists of a rectangular and a triangular faces. Alright. And we can see that there are 3 rectangular faces. I don't know if I can actually draw this thing. I don't know if I should even try it. There are three rectangular faces. One you see in the front, one is in the back, and one appears at the bottom on the floor. There are 3 rectangular faces, and as you can see from the picture, there are 2 triangular faces. The front and the back. Right here in the front and one in the back. Right there. So there are 2 triangular faces. Let's see what they're asking us. Each triangular face has the area of R. Each triangular face has the area of R. So 3 triangular face will have the area of 3 times R. And each triangular face has the area of T. Each triangular face has the area of C. There are 2 of them. So they will have an area of 2T. And the question is, what's the total surface area of the picture? Well, total surface area is the area of the 3 triangular faces. Sorry, I keep calling it triangular. 3 rectangular faces. As I said, one in the front, one in the back, and one at the bottom of the floor, right here. There are 3 rectangular faces. Each of them has the area of R, and there are 3 of them, which means we have 3 R's there. Similarly, we have 2 triangular faces, one in the front and one in the back, and they will add up to 2 times T. and therefore the total surface area is going to be 3 times r plus 2 times t. And that's answer choice B. Answer choice B. Let's do the next one, number 6. As I said in the beginning, this is a very simple, very straightforward question. The first 6 are not going to give you trouble. The next 6 are medium, and the next 6 or 7 are medium, and then last 1/3 are going to be hard. Next one, number 6. I do them because I didn't want to skip any problems, you see. If n is a positive integer and n plus 1 over 2 raised to n equals 1/2, we are told, then how much is n? They're simply asking us how much is n. And they gave us 5 choices here, 1, 2, 3, 4, 5. Just plug them in and see what happens. 1, 2, 3, 4, 5 is what they gave us, so let's start with 1. If you plug in 1 for n plus 1 is 1 plus 1, 2 raised to 1, which is 1 plus 1 is 2, and 2 raised to 1 is 2, which equals 1, and that does not equal 1/2. We are told that it equals 1/2, and of course it does not equal 1/2. A is not the answer. Let's look at B. In B the answer is 2. So we have n, which is 2 plus 1 over 2 raised to 2. Wherever we see n, we replace it with 2. And now we get 2 plus 1, which is 3, and then 2 squared is 4, which of course is not equal to 1/2, because we're told it equals half. B is not the answer. Let's look at C. In answer choice C, they have 3. I don't know why I keep looking at the answer choices. I already realized that it's 1, 2, 3, 4, 5, obviously. So 3 plus 1, n plus 1, which is 3 plus 1 over 2 raised to 3. 2 raised to 3. 3 plus 1 is 4, and 2 raised to 3 is 8. Now we're getting someplace. 8 over 4, 4 over 8 rather. 4 over 8 is indeed 1/2. The answer is C. That's all. I will see you tomorrow, but we'll continue on the next page. Alright? Bye now.